Okay, we're on 6.2. Now we need to conduct a test before we do all these examples, okay? Compare the number with an inequality symbol. So you got 20 and 10. Well, 20 is the higher value, so the sign would have to open up to 20. Now we're going to start conducting some tests. Add 3 to each number and then make the comparison. So add 3 would be 23, 13. Sign still goes the same direction, so put same. Okay. Subtract 3 from each number, make the comparison. Go back up here and minus 3, minus 3. So that'd be 17 and 7. 17 still larger, same direction. So the sign doesn't change when you add to both sides. It doesn't change when you subtract from both sides. Now go up there, divide each number by 5 and make the comparison. Okay. So 20 divided by 5 is 4. 10 divided by 5 is 2. That's the same. Now the next test, instead of dividing each number by 5, divide it by negative 5 and make the comparison. So 20 divided by negative 5 is negative 4. 10 divided by negative 5 would be negative 2. Now negative 2 is the higher value, so I need to switch it. So we had a change there. Okay. The change occurred because I'm dividing by a negative. Okay, change, dividing by a negative. Okay, multiply each number by 2, make the comparison. Well, that'd be 40, that would be 20. Okay, open up towards 40, note same, no change. That's because I'm multiplying by positive. Now when I multiply each number by negative 2, make the comparison. Okay, so it'd be negative 40, that would just be the same thing, but now they'd be negatives. Aha, now negative 20 is a higher value. Okay, so we had a change. Now the change occurred because we were multiplying by a negative. Okay, so when you divide each side by a negative and multiply by a negative, the sign will change. Okay. Okay, now here's the examples. Solve and graph. Oh, there's another graph each inequality. Then I'm going to go to another sheet of paper and kind of remind you of something. Before we go there, make your 8 boxes of doom. Okay. We will be using 2 boxes per problem here. Now, previously this year we've learned how to solve for x. Okay, find what number x equals. So again, x is on this side. The operations are times 3 and plus 9. So I circle the times. We got to get the 9 to 0 first. So I'm minus 9, minus 9. So we got 3 times x. 9 minus 9, so we forget about that. It's 0. 15 minus 9, 6. Then 3 times what? 6. Well, many of you know that in your head, or you can just divide by 3. It's 2. So that's the one answer for x. So I plug it in. If I want to check my answer, I plug it in to the original for x. 3 times 2 is 6. 6 plus 9 is 15. Okay. Got equal answers, so I know I did it right. Now, with greater than or less than, because now they're going to look kind of like this, but now you'll see a greater than or less than sign. There's an infinite amount of answers. See, in this one, 2 is the only answer for that equation. That's the only number that makes this side equal to 15. But when I have greater than and less than, there's a number you'd start with, and then you'd have all the numbers one direction or the other would make that work. Okay? So here's what I need to do. I've got x minus 6 less than or equal to negative 12. You got to be careful on this. It's similar to how you just do the problem I just did, but there's something. First off, you need a number line to represent your answers. You put 0 in the middle. Now, you make a wall on the side of the x like you would with an equals. Okay, there's the inequality. What are your operations? Well, just a minus 6, okay? There's no multiplication or division on this side, so that's good. If there's multiplication or division, there's a question you have to ask yourself, but there's not on this problem, so we don't ask the question, okay? So you get negative 6 to 0 by adding 6. Now when you're adding and subtracting, we drop the sign down as it is. And we have x before the symbol. Negative 12 plus 6 is negative 6, and that is what I graph. Circle, you fill in the circle. And it's opening towards the value, so you take your sheet, okay? And if it opens towards the number, you're going this way. Now you solved it, and I want you to label here's how you label. You just copy that on and put it up here. That's what that means. That's how I want the answer to look, okay? All right, next one. Negative 3 greater than x minus 7. Remember, you need this out here, okay, when you graph. Opens towards or eats the variable, the graph would be this way. Opens towards or eats the number this way. So make a wall on the side of the x. So, over there's a 7, the operation's minus, which will be plus negative. So there's no multiplication, no division, okay? So I get the negative 7 to 0 by adding 7. Then I go add 7 and negative 3. Now you have to keep this lined up, okay? You put your symbol down here, and if x is after the symbol, then it stays after the symbol. You don't put it before, okay? Don't be doing that. Negative 3 plus 7 is 4. So we plot 4 on the number line. The circle will not be filled in. Now, be careful. I know it says greater than, but it's opening towards the number. So when it's opening towards a number, it would go this way, okay? And you just copy your answer down. Now let's prove that that's right, okay? You don't have to do it on the assignment, but I'm going to pick a number with this way. Let's pick 2. 4 greater. Yeah, that's true. That makes sense. Now let's say somebody would have went the other way and picked 6. 4. That's ridiculous. Okay, 6 is a bigger number. It should open up towards 6. It's not, so that would be wrong if I went that way. Okay? So if you follow these rules, you will get it right. Okay? All right, next one. X plus the decimal 0.7 greater than or equal to negative 3.5. Okay, so wall. Only thing's 0.7, the operation's addition, so we take it to 0 by subtracting. Line up the symbol. When you're adding and subtracting, you put x before the symbol. If that's where it's at, fine. Then I take negative 3.5 minus 0.7, that's negative 4.2. Okay, so negative 4.2 is the critical number. You circle, you fill it. It's opening towards the variable, so we go this way. Again, if you're not sure if you got that right, pick a number that way. Let's pick 5, okay? Here, first label it. Put that there. So let's pick 5 for x. Opens up towards a higher value just like it should, so that's correct. If I go on this way, I'd be putting numbers in that would not make it correct. Okay, negative 2x greater than or equal to 14. Now, you've got to pay attention to this part here. Make a wall on the side of the x. Between the 2 and the x, there's no operation, okay? So I put a times dot. If you have multiplication or division, you'll want to circle it. Because now you have to ask yourself a key question that you never had to ask on the first 3. Is that a negative multiplying number? That one right there. It is. You want to circle it. If it's negative, then the sign needs to switch. Here's what I mean by that. You need to take that sign and flip it the other way, because I'm about to divide both sides by a negative number. And on the first part of today's video, remember it flips in 2 situations. When I divide each side by a negative, or I multiply each side by a negative. So you want to circle your division and multiplication. We didn't here because there wasn't any, but now that there is, we circle it. And if it's a negative, you write switch. So when I solve a times, I divide both sides by -2. So I have x, 14 divided by -2 is -7, but the sign has been switched because we knew we were going to divide by a negative. So -7, circle, fill it. It opens towards the number, so it goes this way, and just label it. You can do the check if you want to save time in the video. I will not. Okay. Our next problem, we have -5x less than or equal to 10. Make the wall. 5 and x needs an operation between it, would be times. Now if you have times, you need to circle the operation. You have a negative, so that means we will again switch the sign. When you switch it, give yourself some space. So I only need to do the divide by -5. Because to solve the times with x, I divide. I see times, I have to divide. So x in front and -2 behind it. So -2, circle, fill it, opens to the x, so it would go this way. You got a sheet that tells you that. Okay, next one. 18 less than -9x. Okay, wall between the 9 and the x would be a times. So if you have a times, you want to circle it. Again, you have a negative, so switch. Divide by -9, divide by -9. Okay, so we need to switch the sign, okay? So, those cancel, and we have x, it's behind the symbol, put it behind, keep it on the side it's on. 18 divided by -9 is -2. So I have -2, I circle, I will leave it open because there's no equals and it eats the numbers, so it will go this way. So -2 greater than x. Okay, next one, x over 4 less than or equal to, actually I'm going to make up a new example. If you're on virtual, write it down. If you're on the packet, just watch. 3x greater than 15. Wall, dot, circle, dot, 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 because you have times, okay? This time I'm going to have to divide, but it's a positive, okay? Up here, that was a negative, and the previous problem was negative. But here it's a multiplication, but it's by a positive. So I will keep the sign the same. So I wrote keep right there. So I keep the sign I have. Because see here, the multiplier is negative, so I knew I would switch it. The multiplier is negative, I knew I would switch it. The multiplier is positive, you don't switch it. Okay, it's 3. So to solve the times, I need to divide by 3. So x, 15 divided by 3 is 5. Okay, opens towards the x, so it goes this way. Okay, next example, x divided by 4 less than 5. Okay, make your wall. X and 4, it's a division. So, like multiplication, when you have a division operation, you want to circle the division. Now, the reason I circle it is because I check the number that we have, the 4. It's positive, so we will keep the sign we have. That means keep. So, line that up. Now, to solve a division problem, we need to times each side by 4. Because those operations now cancel, and I have x in front of the symbol. 5 times 4 is 20. Circle, fill it. Opens towards our number, so it would go this way. Okay, next problem. Negative 2/3 x plus 4 less than 18. x is on this side, okay, there it is. It has two numbers with it, the negative 2/3 and the 4, so that's times and that's plus. Circle the times, okay? We have a negative within that times, so we will have to switch the sign, okay? So flip that sign down here. But before you do that, you have to get the 4 to a 0. When I get the 4 to a 0, the sign stays the same because I just have to add or subtract, okay? So again, that's for after I divide, or this is for after I deal with this, but I have to deal with the 4 first. So take it to 0. That would be 14, and then negative 2/3 times x, okay? Now, if I see times, I will be dividing by negative 2/3. So x is in front of the symbol. 14 divided by negative 2/3 is negative 21. So you have negative 21, circle, don't fill it, it opens towards a variable, so it will be going this way. Just copy down what that represents. Okay, next one, we have negative 2, parentheses 6 plus x, greater than or equal to negative 15 minus 2x, okay? Okay, before you even worry about the sign, first off, you got to get rid of your parentheses. So times, here's the plus, put a 1 in front of the x. So negative 2 to 6, negative 2 to 1x. Okay, I'll do that here. Times, actually I'll do it over here. Times 6 times 1x. So it's negative 12 and negative 2x. So line up your symbol. I would put the negative 2x first, so negative 2x plus negative 12. That's now done. There's nothing on that side. And over here I have negative 15 minus 2x. You can make that plus negative. Now you have a problem. You have x on each side. So pick the smaller one. Get it to 0. Oh, there's not a smaller one? They're the same? Cross them out. So this becomes no solution or all solutions. But you don't just check for the exact number now, because now it doesn't say equals, it says greater than, okay? Okay, does it eat the bigger number? Negative 12 is a higher value. Negative 12 is a higher value than negative 15, and it is opening towards that number. So that's all solutions, okay? All right. Next one, 5x plus 7 less than or equal to 22. Just like in an equation, you make sure your x is no parentheses. You make sure you only have a single x, which you do. Make a wall on that side. What are the operations? Times and plus. You want to circle the times. Now, in that circle, do we have a negative or a positive? It's a positive, so we'll keep the sign the same. So keep, okay? So keep it the same. Now, before we come down here, we got to get the 7 to a 0, so there's a step in between. Now, I'm set. I can just fill in the info. Take 7 to 0. That would give me 15, and then 5 times x. Then divide by 5. When you have times, you divide 3, okay? So 3, circle, fill it, opens to the number, so that would be anything this way. Okay, next problem. Negative 3, parentheses x minus 5, greater than or equal to negative 3. Okay, we got a parentheses, we got to deal with that. So negative 3, negative 3. First, you might want to put a 1 there, make it plus negative. So negative 3 to 1x, negative 3 to negative 5. So x with negative 3 and then 15. So line up your symbol, and you're going to put negative 3x plus 15 with the negative 3 on the other side. Okay, how many x's you got? You only have one on this side. So what operations are on that side? Well, that would be times, that would be plus. Circle the times and decide if you have a negative or a positive. We have a negative, so we have to switch the sign. Okay, so that needs to be written in the other direction. Now you have to get the 15 to a 0. When you get that number to a 0, just drop the same sign down. It doesn't flip till you divide, okay? But I know it will flip. See, now I can just fill it in, okay? Minus 15, minus 15. Negative 3 minus 15 is negative 18. Then you divide by negative 3. And you have x in front of the symbol and then 6 behind it. So I plot 6, I circle, I fill it because it's got the, and it opens to the numbers, so it would go this way. It's essentially doing the same thing you did earlier when you're solving just with an equals. You just have to worry about the number line, and also when you're multiplying and dividing, if you have to switch the sign or not. Okay. Next one. 5f. F is the same as x. It doesn't matter. Minus 6. Okay, we don't have to deal with parentheses. How many f's, how many variables do we have? We have 2 of them, okay, or 2 of the same one. Now, if I get rid of the 5f, that's going to be a problem because there's no other number on that side. So let's get the 6f to a 0. So I would subtract 6f, and I would subtract 6f. Now, again, I'm doing subtracting, so the sign will not change. 5 minus 6 is negative 1f. And then you have negative 6 on this side. Now that you're down to a single f, make the wall. Operations times, circle it. Oh, we have a negative, so that will be a switcherooski. Switch it. There. Now, I don't have a number outside I have to get to 0. I go straight to division, come down here. So divide by negative 1 by negative 1. And I have f in front with 6 now behind. So 6, circle, fill it, opens to the number, so it'll be going this way. Okay. F less than or equal to 6. Okay. Okay, next one, we have 6 minus 3x less than or equal to 4 minus x. Okay, follow your process. You don't have any parentheses. You have 2 x's on opposite sides, so what are they? Negative 3 and negative 1. I would get the smaller one to 0 because I still have a 6 on that side. So I would add 3x. And I would go over to the negative 1x and add 3x. Now the sign stays the same. Remember, I don't worry about the sign switch until I have it simplified down to just an x. Okay. So over here we got 6. Over here we're going to have 2x, negative 1 plus 3, plus your 4. Now the wall can come in over here. We have times 2 and plus 4. Circle that times. That's positive, okay? You circle it because now above the circle you put whether you're going to keep the sign or switch it. Now it's a positive 2 times x, so that's a keep. So go at the end and drop it. Keep it. Now you have to get the 4 to a 0 as well, so I have a step in between before I divide. So I will minus 4, 6 minus 4. See, if you arrange the symbols, it makes it that much easier. And we still got 2 times x. Now I divide by 2, so that's 1, and then you have x. Okay, so I have 1. It is opening to the x, so that would be this way. Even though that's a less than sign, it's opening to the x. Because see, if I put a 4 there, it would be opening up towards my larger number 4. Okay, next. Negative 2, 6 plus x, greater than or equal, negative 15 minus 2x. Okay, Okay, we obviously have to get the, actually I already did this problem earlier. That's the same problem as this one, skip that. I already did that problem. 9 plus 2x less than 2x plus 1. Okay, you got x's on both sides of there. Okay, what's the smaller one? Oh, there's not one? Great. So that becomes a all solution or no solution. And also you can get rid of your number line. You don't need that on the all solutions, no solutions. Okay, 9's bigger number, but should open towards 9. It doesn't, so no solution. Okay, next one. 2x minus 8 less than 16 plus 2x. Okay. So we're going to have to distribute. Get rid of those parentheses. Okay, so 2, make your number line. You might need it, you might not. 2 times 1x and then negative 8. So it's 2x and negative 16. So line the symbol up. 2x plus negative 16. Okay, x's are on each side so I don't make my wall. Oh, they're the same? Guess what? Okay. Becomes all solution or no solution. And I don't need my number line then. Okay, positive 16 is a higher value. Is a sign opening towards that? Yes, it is. Okay, it's all solutions. It has to open towards your higher value. Okay, and then our last one, 6x minus 4 less than or equal to 2, 3x plus 6. Okay, so you have to distribute your 2 because you have to get rid of the parentheses before you worry about anything else. 3x times 6, that's 6x, and that's 12. And over here you got 6x minus 4. Okay, normally now's the time I get my smaller x to 0, but there's not a smaller x, they're identical. Okay, so cross them out, and that becomes all solution or no solution. Well, positive 12 is a higher value, and it is opening towards 12, so that's all solutions. Okay. All right, now your assignment right there. Please make sure you are making the wall, once it's simplified so you only have a single x, please make the wall, put the operations. On the multiply divide operations, circle them. If you have a negative, the sign must switch. If you have a positive, you leave it the same. See, these first 3 I don't even have multiplication or division, so the sign will not switch. Number 4, 5 times x, I'll circle the 5 times x, but the 5 is positive, so the sign will stay the same. Number 5, okay, it would be negative 6 times x, so I have times, I circle it, and since it's a negative, the sign has to switch, because we have to divide both sides by negative 6. Okay, number 6, wall, okay, negative 2 times x, circle it, I can see I have a negative 2, so the sign switches. And also, you got to keep the x. If the x is after the symbol, it stays after the symbol. Okay, x divided by 3. You have divided by. You got to circle the divided by. There's no negative in there. It's positive 3, so that we keep the sign the same. Then we times by 3 on each side. Okay. Number 8, negative 3/5 x. So that's times x. We circle. I think that's a negative in that circle, so the sign will switch. And then I just divide by the negative. Okay. Number 9, 4x minus 1. So that means 4 times x minus 1. So I circle the 4 times x, but since the 4 is positive, okay, the sign will not switch. It'll stay the same. Of course, I have to get the negative 1 to a 0 first. Okay. Okay, let me know if you need some help.